Hello, good morning everyone. So now I will start with the next session of the search technique. So here some typical search process are discussed, and among that search, what are the parameters to be required in any search technique? It's shown. Okay. So in first standard for any standard searching technique, there should be a set of state. Okay. So as I have discussed in the last class that what is state. So in any standard search technique, a set of state should be provided. Okay. And after that, operators and their cost. You have seen that in last class that I have followed a minimum path and have reached from initial to goal state. Okay. So what kind of operator was used? It was directly, it was the next successor. We have considered the next successor operator, and then the minimum cost was also discussed. Okay. And third one is start state. Okay. So from which state we will start? We started in the last example, we started from initial state. Okay. So now the last point of the search parameter is searching technique is a test to check the goal state. That means we have to check that we have reached to the goal or not. When the goal is reached, then we can terminate the search engine. Okay. Now the basic search algorithm is shown in the box format. So here it has been said that let L be the list containing the initial state. So where L is named as a fringe. Now loop. How this loop will work. If L is empty, return failure. Now from select L to node. After that, if node is a goal, then return to the node, the path from initial state to node. Else, if node is a goal, then the return to node. That means the loop will end. Okay. Else, generate all successors of node and merge the newly generated states into L. Okay. So this process will be continuing till we search the goal, and after that the loop will end. That means end loop. So this particular box is showing the algorithm which I have discussed in last class, and you also go through with this node which I have already uploaded in Microsoft Team, and the description of this algorithm I am right now uploading in YouTube. Okay. So now here I will read out what they have given elaboration. In the elaboration part, what they have given. So now we need to denote the state that have been generated. We will call these a node. As you have seen in last class, I have shown you what are the nodes. The data structure for a node will keep track of not only the state but also the parent state or the operator that was applied to get this state. Operator means there we have calculated the minimum distance. Okay, that one was the operator in the last example. Okay, so but also the parent state and the operator that was applied to get this state. In addition, the search algorithm maintains a list of nodes called the fringe. In addition, the search algorithm which maintains a list of nodes called the fringe keeps track of the nodes that have been generated but are yet to be explored. So when the node which is a child node, after that child node, if some of the dotted lines which was in light color, if some of the dotted lines are provided, that means we have a path. But how that path will be followed? If the goal is nearby to that particular fringe, then we will again explore the fringe and expand the fringe, and then we will find out the new child. Okay. So that particular state is called as fringe. Means when one child has been created, and after that child, when it will become a parent again, and it will create two more new children. So those children will be called that the previous fringe is expanded into the new fringe. Okay. Now the means activation. When it will be activated, that period will be called as, when the nodes will be activated, that period will be called as fringe. The fringe represents the frontier of the search tree frontiers of the search tree generated. I have told you right now. The basic search algorithm has been described above. Initially, the fringe contains a single node corresponding to the start state. You have seen it in that last YouTube video also. In this version, we use only the open list or fringe. The algorithm always picks the first node from the fringe for explanation. If the node contains a goal state, the path to the goal is returned. Okay. So when we will reach goal state, that means that is the terminated point of the algorithm. Okay. The path corresponding to a goal node can be found by following the parent pointers. Otherwise, all the successor nodes are generated and they are added to the fringe. You have seen in the last video that when it is generated, because of the because of those light dotted lines, we get to know that okay, there is a path. Okay, there is a provisional path. But when it will be solid line, if we see that the cost is minimum to reach the goal, then only we will draw the solid lines. Okay. Now the successors of the current expanded node are put in fringe. We will soon see. Okay, so some examples are given in next page. So it has been written over there. Okay, like that. Now search algorithm. There are some key issues. Now what are those key issues? Okay, so which node should we select for the search engine? Okay, for the search algorithm. So initial state, we have to decide the initial state first. And then when we get a search tree which contains the generated and the explored nodes, the search tree may be unbounded. This may happen if the state space is infinite. So when we have to do some search in infinite mode, then it will be unbounded. That means our goal state is not defined. Okay, so that is one kind of search. This can also happen if there are loops in the search space. So how can we handle those handle loops corresponding to a search algorithm? Should we return a path or a node? Where we will return? You have seen in the last example that the answer to this depends on the problem. For problem like n queens, there are some different kinds of problem which will be where we have to consider either the path or a node. So in the last example you have seen, we were returning to the node. So there will be some kind of example where we have to return to the path. Okay. So there are different types of parameters which we have to consider, and what will be the consideration, how we will consider depending on the problem itself, what problem is given to the user. So as per that one, we will instruct the machine and the machine will do such the same thing. Now we see that the basic search algorithm, we have to select a node for expansion. Which node should we select? How would we place the newly generated node in the fringe? We will subsequently explore various search strategies and discuss these properties. Okay. So depending on the search problem, we will have different cases. So what those different cases also we will discuss as per the problem. Which path to find? The objective of a search problem is to find a path from the initial state to a goal state. That is the objective. If there are several paths, which path should be chosen? Our objective could be to find any path, or we may need to find the shortest path or the least cost path. So it will totally depend on the problem itself, which path we have to follow. If some instructions are provided, then definitely we can choose. We have to choose the instructed values only. And if no other instructions are given, then we can write all the paths which will lead towards the goal. Okay. So this is some example or some key issues with the search engine or search technique. Okay. So now evaluating search strategies, completeness. We need a search to be completed. Okay. Optimality. Does the solution have low cost or the minimal cost? Okay. What is the optimization of that one? Okay. Now what is search cost associated with the time and memory required to find a solution. That is time complexity and space complexity. Okay. Now, after that, there are some blind search also. Okay, those blind search are named as BFS and DFS. So these are the some evaluating strategies. Okay, so here three of the strategies. Here three of the strategies are provided: completeness, optimality, and time complexity and space complexity. Okay, and in other part, the different search strategies that will be considered including following: blind search strategies or uninformed search. So those uninformed search may be depth first search, width first search, iterative deepening search, iterative broadening search, then informed search, constraint satisfaction search, advisory search. Okay, so there are some kind of classification in search technique also. Okay, so I will be ending this recording here, and in the next video I will upload it. Okay, thank you.